Foundations of the right triangle. So we're going to go through some useful characteristics of the right angle triangle. They may or may not be familiar to you. So at the beginning, we're just going to go through some terminology. What we have here are the 6 trigonometric functions that we are going to be working with. They all are ratios of the sides of a triangle with reference to one of the specific angles. So as you can see from our right angle triangle on the right here, we have a 90 degree in the bottom left corner, and then we have a theta in the bottom right corner. So when we're saying that we're making ratios with reference to an angle, this is the angle in question here. The first thing you need to do when you identify an angle, we look at the sides of the triangle. We want to use the 3 different words: opposite, adjacent, and hypotenuse. So the hypotenuse is always going to be across from the 90 degree angle. Opposite is going to be across from the angle that has the theta, and adjacent is always going to be the length of the side attached to the angle theta. Now here we have a 3, 4, 5 triangle, and when we're asked to find the 6 trigonometric functions, basically what we're saying is, for the sine function, find opposite over hypotenuse. So sine theta, opposite over hypotenuse, is 4/5. Cosine theta is adjacent over hypotenuse, which would be 3/5. Tangent is opposite over adjacent. Opposite over adjacent is 4/3. These ones you may have heard of before, and there's a little phrase, Soh Cah Toa, which helps people remember that phrase, or the ratios. So the sine function is opposite over hypotenuse. The cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now the other 3 may not be familiar with: cosecant, secant, and cotangent. These are the reciprocals of sine, cosine, and tangent. So as you can see, here we have opposite over hypotenuse, the reciprocal, hypotenuse over opposite. Adjacent over hypotenuse, hypotenuse over adjacent. Opposite over adjacent, adjacent over hypotenuse. So as long as you know the first 3, you should be good with setting up the reciprocals. The only, example 1, find the values of the 6 trigonometric functions for angle G. So here's angle G. First thing we want to identify is the hypotenuse, the opposite, and the adjacent. Hypotenuse is always across from the right angle. Opposite is opposite the angle and adjacent. Now I need to come up with sine theta, cosine theta, tan theta, and the other 3, which is cosecant, secant, and cotangent, which are just the reciprocals. So if we can find the first 3, sine is opposite over hypotenuse, so 24/40. And then we do want to simplify that, 3/5. Cosine is adjacent, so 32 over hypotenuse, which is 40, which would simplify to be 4/5. Tangent is opposite over adjacent, so 24/32, which simplifies to be 3/4. Now to find cosecant, I can simply just take the reciprocal. So we get 5/3. Secant would be, that's an equal sign, not a negative, 5/4. And cotangent would be 4/5. No, I lied, 4/3. In a right angle triangle, angle A is acute. So remember, acute means between 0 and 90 degrees. Tan A is equal to 5/3. So tan A is opposite over adjacent, which is 5/3. So here's A, opposite, adjacent, and hypotenuse. Find the value of CSC, which is cosecant. Well, cosecant is the reciprocal of sine. So if we find sine, then we can find cosecant. Or we can look at it like, I know that sine is hypotenuse over, sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So the first thing I need to do is I need to find out what that value of C is. And to find the value of C, I can use the Pythagorean theorem. So C squared is equal to 3 squared plus 5 squared. So C squared is equal to 34, and C is equal to root 34. So we really have root 34 over opposite, which is 5. There are two triangles that you need to memorize and know. They're called the 30, 60, 90 and the 45, 45, 90 degree triangle. The reason why they're so important is because they're the foundation, the angles which are the foundation of all trigonometric functions, and eventually you will be using these angles to create a unit circle. A unit circle is used to create a graph of a trigonometric function. A graph of a trigonometric function is used in math, in physics, in engineering, so you will see it often depending on what your path is. Now, the 30, 60, 90 is in the top here. Now what I want you to notice is that across from the 30-degree angle, we really have a 1. Across from the 60-degree angle, we have root 3, which is a number that's slightly larger than 1. And across from the 90, we have a 2. Now the reason why there's an X here is that if we increase the length of the sides on one side, let's say we increase this length, in order for the proportions or the angles to remain 30, 60, and 90, we would have to increase the length of each other side by that same unit of X in order for the angles to be a 30, 60, 90. So as long as you know that we have a 30 and a 60, across from the 30 is 1 unit, across from the 60 is root 3, across from the 90 is a 2. And it works in terms of Pythagorean. 1 squared plus root 3 squared is equal to 2 squared. True. Our 45, 45, 90 is based on the fact that if both of these angles are 45, that means that their opposite lengths have to be the same distance. So 1 squared plus 1 squared is equal to root 2 squared, which is true. So our 45, 45, 90 is 1, 1, root 2. Now the reason why we need to know that is because often we will see angles of those ratios. Use the trigonometric function to find the value of x found to the nearest tenth if necessary. So we want to find x. What we're given is only an angle and one side. So if we think of a right angle triangle, notice that this is rotated. So across from the 30 is 1, across from the 60 is root 3, and across from the 12 is our 2. And then I put these x's in. So what we're really saying is that 2x is equal to 12. So x is really equal to 6 because 2x is the hypotenuse, and all we're doing is using similar triangles, which is equal to 12. So x is equal to 6. So if I want to find the length of the adjacent side, that would just be 6. But I'm really looking for this length, and this length here is really x times root 3. So my answer is 6 root 3. To calculate the height of a building, Joel walked 200 feet from the base and used an inclinometer to measure the angle from his eye to the top of the building. If Joel's eye level is 6 feet, what is the distance from the top of the building to Joel's eye? So here's our situation. We're given 76 degrees, 200 as our adjacent. So if you look, we have adjacent. This is going to be hypotenuse because this is our right angle triangle. So the trig function that uses adjacent and hypotenuse is cosine. So cosine theta is equal to A over H. Cosine of 76 degrees is equal to 200 over H. I want to find my H, which in this case is my D. I'm going to multiply both sides by D. I get D cosine of 76 is equal to 200. And then divide both sides by cosine 76. Then I'm just going to go to my calculator and plug in 200 divided by, hit the cosine button, 76. And the calculator will tell you an answer of approximately 826.7. Now make sure your calculator is in degrees, or else you will not get that answer. And to check that, you would press the mode button. It could be in radians or it could be in degrees.